Hey everybody, Gene from Gene's Green Machine. Getting a lot of questions about charging batteries with my pedal generator. So I wanted to do a little deep dive into the different ways to charge batteries, which ones to charge, how much watts each one takes, that kind of thing. So let's get started. So this is a USB-C battery pack. Unfortunately, again, only takes about about 12 watts or so to charge. Let me just try that one just for demonstration purposes here. Yeah, just about 12 watts. From dead, this is a 37 watt hour battery pack. Will take about 4 hours to charge at that pace. So at 12 watts input, 3 or 4 hours. But usually it's 4 hours because it'll go get to 80% and then it'll taper off the actual number of watts that it puts into it. And that's the same case with cell phones and with other battery packs. So 1 amp input, so that's 5 watts. Again, probably take about 4 hours to charge because it's charging slower than the USB-C battery pack. This is a quick charge battery pack, quick charge 2.0. Actually, quick charge 3.0 output, but 2.0 in. It is a 38.5 watt hour battery pack. Actually, it's only taken about 4 watts because it's almost charged, so it's on its taper to full charge. So actually, it'll take about 13 watts when it's needing a full charge. Here's a laptop computer. This is a Surface Pro 3. I was able to get an automotive charger for it that I just plug into my pedal generator because the volts I'm going to generate are between the 12 and 15 volts that it expects to, much like you would have in a car. So let's see how many watts it takes to power this, charge this laptop. So I'm up to 13 volts charging, and we're hovering just about exactly 29 watts. How about a USB-C laptop? This is a Lenovo Yoga. It's got a USB-C charging port on it. I have this USB-C. This is an Aki brand USB-C charger. So this sadly doesn't go as high as the Surface Pro 3 as far as wattage goes. Actually, it only goes to about 11 watts going into the laptop. So this is a portable battery pack, jump starter. Anyway, I've got this one plugged into my pedal generator. Because I have the bridge rectifier in there, it keeps the voltage, the power from going down into the motor and spinning the wheel. So the voltage on the meter reads right now 12.411 volts. That's the charge on this battery. So anytime I'm pedaling, generating more power than that, more volts than that 12.411, I'm actually going to put watts into the battery pack. So let's see how many watts this battery pack will take. Now I don't want to go above 15 volts because that would potentially damage this battery pack. So I can go right up to 15 volts, but no more than that. So let's see how many watts it'll take. So right at 15, it looks like the battery is absorbing about 32 volts, or 32 watts. I'm sorry, 32 watts, and just about 2 amps. All right, so let's add a second battery pack. So let me just use the jump starter wires from this jump starter. All right, and then I'll turn this on, which gets the voltage from both of these in there. So then my voltage changed to 12.75. So this battery looks like it's got a little more charge than the battery pack does. So let's see if the two batteries will take more watts than the single battery. At about 15 volts, the wattage that's being absorbed is 42, 43. So I picked up about 10 more watts going into the battery bank. Lead acid batteries, they're not very efficient. They're about 85% efficient. So if you generated 100 watt hours, you'd only get about 85 watt hours back out of it. So more ideal battery types are lithium ion batteries or LiPo batteries, which are pretty close to 100% efficient in the watts you put in versus what you get back out. Ended up getting is this 12 volt automotive battery charger from my Makita, and it turns out that I can charge this. It takes about 70 watts to charge. Said I need the battery pack, this lead acid battery here, to help smooth out the charge, because the draw from this battery is about 70 watts, but it's kind of spiky at first. As things get started, it's taking in about 65 watts, 70 watts. Now the cool thing about this, using this as a battery pack to charge, is Makita has a bunch of accessories, and one of them is a USB charger. So I can use this USB charger to charge my mobile phone. Makita also has, I don't know, 100, 200 different accessories, chainsaws and sawzalls and cut-off saws and just about any kind of other device you'd want to use, flashlights, tons of different accessories that you can get with this setup, where you can use the 12-volt charger to charge it. You can have power for a number of different things in case of emergency, or for living off the grid. The cool thing about this little balance charger is it'll charge all kinds of different batteries, LiPo batteries, lithium ion, nickel metal hydride, NiCads, lead. It's got a input voltage range, DC, of 11 to 18 volts, which matches up very nicely with the pedal generator setup. This is a 5.5 amp hour, 11.1 volt LiPo battery. This will take right on up to about 80 watts of charge, which gives me about 80 watts of resistance by itself, which makes for a good workout. But one of the advantages of using one of these smart chargers is I can change the how many amps go into it. So right now it's an S3, so I have to leave it S3, but I can go change the actual amps that go into it by just tweaking it down. So if I have other things that I'm charging and I don't want to, have this go at the full 80 watts, I can bump it down to, or down to 3 amps, which will give it a little easier workout. So let me see what that does when I fire this up. And I need to be spinning and have the lead acid battery plugged in, or this charger complains about not having enough current. So with that, at 3 amps, the draw on this is about 40 watts, which I expected it to be. So now if I stop this and go back and change this back to 6 amps, which is the max of this charging unit, let's fire it up. 80 watts going into it. One of the problems with LiPo batteries, you don't want to over discharge it. You don't want the voltage to go too low. I've made this little rig to plug in those car adapter sockets. Put a meter in there just so I can see how many volts it's reading. But I added this low voltage disconnect, which has different toggles for the different depth of discharge. I've got it set at 10.7 volts. So hopefully this video has been informational for you, showing you how to charge various different types of batteries, from LiPo batteries to lithium ion batteries, battery packs, to cordless drill chargers, to lead acid batteries, your cell phone, and so on. If you have any questions about how you could charge other things, certainly leave a question in the comments below. And if you like what I'm doing, please subscribe.